Okay, homework from section 9.3. For number 3, know that y prime is the same thing as dy over dx. So you're going to multiply dx over to the right, leave this x where it's at, but divide this y over to the other side, and then divide by x squared plus 1. On the left side, the integral is natural log of absolute y. On the right side, you're going to have to do a u substitution. And the u is x squared plus 1, the entire denominator. And then x times dx is replaced with 1/2 du. And you wind up with the integral of 1/2 times 1 over u du. When that's integrated, we end up getting 1/2 natural log of the absolute value of u, where u is x squared plus 1, and then plus unknown constant. Before I can isolate y, everything has to be absorbed into the natural logs. So the left side is already a condensed logarithm. The right side is not a condensed logarithm. First of all, the 1/2 multiple becomes an exponent. Now, I don't actually need the absolute values because x squared plus 1 is always positive. The exponent 1/2 is a square root. Then I have a plus unknown constant. Now, that unknown constant can also be the natural log of another unknown constant. So right now I'm saying that c is equal to the natural log of some other unknown number d. I need to do that so I can condense the right side of the logarithm. And the log rule says if you're adding two logarithms, that's multiplying the insides. So I have the natural log of some unknown constant d times the square root of x squared plus 1. Then I can take the absolute value signs off, first undo the logarithm, e to the power, both sides, but I can only do that with condensed logarithms. And absolute value of y comes out. And then I can take off the absolute value, change it to a plus or minus, and I can allow that to be absorbed into this unknown constant. And now I'm going to make another letter representing an unknown constant. I'll use capital A to represent plus or minus whatever d is. And this problem was not did not give an initial point. So this is as far as you can go. Number 10. In order to solve number 10, first I need to subtract over to the other side e to the t plus z. Now I can multiply both sides by dt, but I have to separate t and z through multiplication. And I have to remember that there is an exponent rule. I've got my negative from up here, and I can separate the t and the z if I multiply by the same base of an exponential. And that's going backward on the rule, excuse me, the rule. When two exponentials are multiplying with the same base, you add the exponents. And dt. Then I can divide by e to the z so that I have all of my z's on one side, my t's on the other. And I need to rewrite the left side as e to the negative z. And now I am ready to integrate. I need to do a u substitution with the negative z. And that will give me an extra negative sign. So I wind up getting negative the integral of e to the u du, which will then integrate to negative e to the u, plug the u back in, and the left side is integrated. On the right side, I have constant multiple negative 1, and then e to the t, integral is e to the t, plus unknown constant. And now I'm going to have the negatives, I'm going to multiply both sides by negative 1. And if I want to solve for c, or sorry, if I want to solve for z, I need to, excuse me, I need to take the natural log of both sides. On the left side, the natural log and e cancel each other out, giving me negative z. And then multiplying by negative 1 allows me to isolate my z. And then there are different ways that this particular answer can be written. For example, it could read negative natural log of e to the t plus unknown constant, I'll say capital K. Also, another way it could be written is the negative multiple in a logarithm is allowed to become an exponent. And if it's an exponent, if negative 1 is an exponent, then that means reciprocal. So a variety of ways that z can be written. Then, for the next problem, I'm going to isolate my y's. I need to multiply dx over to the right side. And then I'm going to leave cosine x on the right. And I need to bring all of these y's to the other side through multiplication division. Now that the variables are separated, it's time to integrate. To integrate, I cannot deal with division, so I need to distribute the division of the y, which gives me 1 over y plus y squared over y, which is y. And now everybody's ready for integration. Integral of 1 over y gives me the natural log of absolute y. And then integrating y, I get y squared over 2. Integral of cosine gives me positive sine x plus unknown constant. And we have an initial point to use. Y of 0 is equal to 1. So I'm going to plug a 1 into the y's. The natural log of 1 is 0. And Then we get plus 1/2 equals plugging 0 into sine. Sine of 0 is 0. So I'm getting that c is equal to 1/2. And I cannot isolate y in this situation. So this is the best I can do for a solved particular solution. And then one more problem. Number 35. For number 35, we want to realize that k is an unknown constant, m is a specific constant that we are not aware of, and our only variables are p and t. As I separate the variables, I need dt to go on the right, and my life is going to be easiest if I let the k be where it's at. In fact, if I really want to make my life easier, I'll leave a negative k so that my variable p is only multiplied by a positive 1. So let me show you how to do that because it will make your life much easier. So I'm going to leave negative k and divide by p minus m. So I'm changing this. Now when I do a u substitution on that left side, where u is equal to p minus m, again, p is the only variable here, du dp is positive 1 only. That means du is equal to dp, and this is now just 1 over u du. When I integrate, I end up getting the natural log of the absolute value of u. On the right side, I integrate a constant with respect to t, and I get that constant times t plus unknown constant c. Now, I want to isolate p, so I'm going to e to the power both sides. That gives me the absolute value of p minus m equals e to the negative kt plus c. The absolute value is a plus or minus sign. When I have addition of two items in an exponent, that can become multiplication with that same base. And I'm going to put the c in front and then the negative kt. So now it is p minus m equals some unknown constant. I'll give it a capital A times e to the negative kt. And I can solve for my unknown constant. Or am I able to solve for my unknown constant? I do not have an initial point, so I cannot solve for my unknown constant. And I'm just going to be able to say that p is equal to, add m to the other side, plus unknown constant a times e to the negative kt. Now it asked what is the limit of this expression. It probably should have been more clear, but it was asking what is the limit as t approaches infinity of p with respect to t. And if t is heading to infinity, negative constant that is positive times t is heading to negative infinity, and e to the negative infinity is heading to 0. So I wind up heading to m. And that is it.